Hi, I'm Anand, founder and CEO at Technogize. We are a small boutique company based in Pune and Bangalore. I was supposed to run this session with Vishal, who's my colleague at Technogize, but he could not travel. So thanks to Sunit. Sunit has been good friend, mentor, ex-colleague from the past. He has agreed to present along with me, and even more good because he has written a book on it. So we are going to talk about that book towards the end. About engineering intelligence and metrics.
Hello, welcome back. Yeah, so I think it's a nice segue from the previous one where we talked about DevX and how we can make the DevX more successful to the next where we talked about metrics also, but we talked very narrowly on just about developer experience. This is more around the engineering metrics and how we can have the engineering intelligence. That's the topic. So first let's start with the common challenges, right? One is the DevOps, but generally overall, what are the common challenges faced by engineering teams? The first one is time to market. I want it today, I want it now, I wanted it yesterday, so when you can give me, right? And we don't have predictability also, because there is no measure like, okay, I can measure this is how many square foot and I can build this much square foot and then I can do it, right? So it's very difficult to give those answers that how we can go live, when we can go live. Predictability is challenge and customer wants it or our client wants it today. So that's one of the biggest challenge of the engineering teams. There are a lot of development inefficiencies, which is what we talked about in the last session also, that developers are taking ages. Why? You just have to do this API call and get it done. But to get that API call done is a nightmare for us. To integrate with the other systems is a biggest challenge. Onboarding. Oh, you have the developer. Why is not working? Oh, he doesn't have a laptop. He doesn't have an ID yet. And that's where the challenge starts. And nobody is able to articulate this also well, right? That why we are running slow. Everyone thinks that IT is slow. Whereas IT needs to make everybody faster, we are ourselves running slow. Then comes complexities at scale, which is, okay, you might be able to do some improvement in one of the pod, one of the application, in one of the small, and you can say, yes, we did it. But when it comes to organization, there are 200 plus applications. There are 200 plus teams working. In each application, you can have multiple teams. How do you go about looking at all of them and try to improve their life, improve the overall efficiencies across, right?
And the larger the organization, you see those innovations in pockets.
Yes.
Some things are being done great in one team. The moment you shift to another team,
same problem.
Totally different, different problems.
So that's the major challenges that we have seen in the engineering teams, followed by what are the anti-patterns of addressing them. Oh, you want to get it done faster? Add more developers to it. Okay, let's do more meetings to solve this problem. Come together, we'll do a workshop and then we'll discuss the same thing again and again. And then no time for development, no time to do actual coding, right? We say that, okay, now we have a hero, we'll do all the things for you. We have brought this person into your team who has solved this problem and he'll make things all great. And at the end of the day, we are waiting for that hero to do all the magic for us by day and night working or whatever it is.
Typically, consultants like us face that day in, day out, where we are those heroes, like come in and just solve the problems.
And instead of building capabilities and expertise, we are investing in building heroes, which is also not very good for the organization. And at the end, we end up having quick sick, array, do something, make it work, do this hack, get it out of the door so that I can tick the box. And then again, say that engineering team did a bad job because this is failing for 9 use cases, you made it work for only 1. But nobody realizes what has gone into it, right? And these are the challenges for us as a engineering teams, engineering leads, that we are not able to solve it very elegantly. Or even sometime I would say that we are not able to even highlight it or project it very elegantly. That what is our problem, where we have a problem, right? And that's the key challenge that we are trying to help here in this talk. So is there a better way to solve this problem? So let's take an example that if you have such problem in business, what do you do? Any quick thoughts?
Quick thoughts.
If you have a business problem, what do you do?
We brainstorm that problem, we try to find the root cause.
Yes.
Correct.
Yeah. To do the root cause, what do you do? You look at some data, right? You bring the data. You try to set up we call it as a business intelligence platform or business intelligence, right? We have reporting where we can see, like one of the example that I can give is that if we have drop off in our journey, in the consumer journey, if we have a drop off, what we do? We try to find out where people are dropping by bringing in the business intelligence, correct? And that's the same theory we need to apply for ourselves in engineering. We are solving problem for business. Can we solve our own problem? That's the key here, and that's what the ask here is. We know how to solve this problem. We have solved this problem for business. We just have to solve this problem for ourselves. Have you all know about business intelligence? Yes? Raise your hand. Have you all heard about it? Have you seen the business intelligence? Correct? We don't have to do anything different here. We just have to apply the same concept into engineering intelligence. We have to bring our own data out. We have to think and do our decisioning based on data. If I have a data, I can showcase my management where the productivity losses, what you need to do, what you need to invest in to make that better, right? And that's exactly is what engineering intelligence is all about. So engineering intelligence platform enables engineering team with data driven intelligence. We keep saying to business, right? Oh, your decision should be based on the data. You can't think just that this is the problem. We are saying that you apply the same lens, same philosophy in our own world. That's all. And this is what is the talk about. So it can help eventually to improve productivity, better developer experience, better predictability also, right? And then you have the better decisioning at the end. So drive better engineering outcomes through data is the key. The same philosophy we apply for the business, and use these metrics to improve your time to market, quality, developer experience at the end, right? Which will eventually give you the business outcomes. So what we can measure here, right? That's the next question. Oh, okay, I want to do this engineering intelligence that you are talking about, but what should I measure? I think that will vary also, but will give you some ideas on how you can think about this. So we have created 4 categories of engineering matrices. These are 4 different things to measure, 4 different areas, and then metrics on each of these categories. Based on where you want to focus first, you can start, or you can start parallelly across. What kind of metrics to measure is also, we'll share some of those, we'll share examples as well, and then you can apply and have different metrics also. There is no problem there. It's all about thinking in that direction, because I cannot say that for every business you do 4 metrics and every business will solve the problem, right? Based on your problem statement, you have to come up with what metrics to measure. We'll give you some examples of that. So the first one is related to delivery metrics. So these are metrics that revolve around understanding our overall performance about software delivery. All of you must have heard of DORA, correct? So DORA matrices are related to the delivery part of it, which is the last leg of the overall software development cycle, right? Where you are done with the development, and post that you have all these metrics available around delivery, which are deployment frequency, how frequently you are deploying to production, lead time for changes, which is your time. In DORA, it talks about commit to production deployment. You can further stretch it a little bit behind that, okay, it has come in the development queue to production. So more you stretch it further, better. But you can look at that. change failure rate, mean time to recover. I don't want to explain much on that because most of the people in this room might have heard and aware of this. So these are delivery related metrics. So if you want to monitor your delivery and have the observability, the metrics around it, this is the few examples of it. However, feel free to create or add whatever you like, but be careful. Don't have too many things to monitor. Otherwise, that will become a burden. Based on your problem statement, based on your areas of improvement that you are looking on, define what you want to measure and what you want to follow. Second is the quality metrics. So if you have a problem of quality, you can look at it, what are the different quality metrics that I can follow, which will help me to have a better quality software out and release faster also, right? So you can say code complexity. Test coverage is one of the most followed in the industry, that how much automated test I have which will help me to do faster or the frequent delivery, right? And build failure rates. So whenever I commit, my build is failing. How many times the builds are failing, right? Tech debts. How you measure tech debts is one of the biggest problem in the industry, and we don't have any direct ways to say that, okay, this is the X tech debt in the overall project. We need to come up with the ideas on how we can measure, how we can project that we are adding a tech debt through help of ADRs, through help of some mechanism there. The third one is the developer experience that we talked about in the last session already, right? These metrics help to understand developer effectiveness, how effective developer are. And few of the examples that we talked about is already onboarding time, happiness index, service resolution time, code review cycle time, right? So Pramida was talking about in the last session where instead of measuring how many code review comments the reviewer is giving is a bad way to measure, rather than you say that how much time it takes to solve the code review cycle time. And can you use AI for that? So there could be a two-step review. As soon as developer done with the development, they can have some AI tools which can do first round of code review for them in the IDE itself. They'll fix all that basic stuff. So we used to have that Sonar Cube and all that. Now there is a AI also on top of that, and then go into the code review, which will help to reduce the cycle further. And the next person doesn't have to look for the common things. They can look for the more complex reviews that they can do, right? And give feedback quickly. And if you have a tool, integrated tool in the Git ecosystem, then as soon as they send a pull request, the other person can review itself, give it back, give the comments back into the same, and it can be again committed and review is done, right? So if you have an integrated system within the IDE and the Git, it can reduce the overall cycle time, right? So think of from that perspective on the developer experience side of it. And the fourth one is related to the operational metrics. So which is more around, are we running this software effectively in production and keeping the lights on, like similar to system uptime, resource utilization. This could be a very helpful metrics when you are in AWS and all, right? If you know the utilization, you can optimize your resources and bring your cloud cost down, right? So if your cloud cost is high, which is your operational problem, you can measure metrics which is related to resource utilization in the cloud. And that way you can bring the cost down and then have that available as a information to everyone, so that every application team can look at their own utilization in the cloud. Then incident time, cost, cloud cost per customer is another example that people are measuring now. It is also called as unit economics, unit of economics, like that, which is the type of metrics that you measure for operation. So these are the four categories that we talk about when it comes to the engineering matrices: delivery metrics, quality metrics, developer experience metrics, and operational metrics. Based on the problem statement, based on what you want to measure, you can pick 2-3 metrics from each of the category, have them available for everyone to view. We'll talk about this further, that how you can make this setup done and all of that.
Anybody here measures any of these things? Nice. Anybody measures velocity? Yeah, most of us end up measuring velocity as one of the metrics because that's visible to the business and that's visible in the sprint board. But I think all these metrics, and we'll talk further about how they would be helpful to measure this.
Moving on, if you look at these metrics, there are two categories of metrics that we talk about always, right? And we need to understand these metrics as a lagging metrics or a leading metrics, right? So lagging indicators will give you the results later. Leading indicators will start showing you the outcome as you are doing the development. So delivery metrics that we talked about, most of them are lagging, where software is deployed to the production, and that's where you start getting to see the numbers and all of that, right? Whereas quality related metrics, for example, test coverage could be the leading indicator. As soon as you check in, your tests are run and you get the feedback immediately that your coverage is good, move on. And better the coverage, will show you some sample that how that leading indicators give you benefit at the lagging indicator also. And you can track them also and see the trends over a period of time. So overall objective is to improve on the lagging indicator, whereas you can have the leading indicator which leads to that. So that's very key that you understand this difference very well and then have the correlation also defined and see if that is working for you or not. So yeah.
The key here is to connect these engineering metrics, the 4 kinds of metrics and different metrics that we talked about, to connect this for better business and engineering outcomes both. Having focus on just one would not lead to success. These are some of the samples that we have picked up from our experiences and our projects. The businesses generally ask faster delivery. The teams also generally ask faster delivery. What are the good metrics to track, to achieve that goal, right? So focus on this delivery and quality metrics when you are trying to get to the faster delivery. Some of the examples are focus on DORA metrics, focus on code commit analysis, what people are committing, how much are those big commits, small commits, how frequently people are committing. What is the code complexity? Continuously measure whether the trend of code complexity is going downwards or upwards. The test coverage, the build and deploy time. If these are improved, we automatically will get into the faster delivery. Okay. Reduce cost, as Sunit was talking about, cloud per customer and so on. Focus on delivery and operation metrics. Some of the samples are, again the DORA metrics. The cost would go down if we are deploying frequently and so on. Cloud per customer and the SRE metrics. The more incidences we have, the higher is the cost of building or rolling out the feature. If there are lesser incidences, the lower the cost. We want better predictability. That is something that we keep hearing from the business and the stakeholders, right? How can you predict better that when can I take this product live? And rightly so, right? A lot of things are dependent on us. Unless we commit to a timeline that it's going to go on X days, the business can't plan their further steps ahead, like marketing, the support, the rollouts and so on. There are so many things. But if we can't give predictability, then all those things takes time. So if you want better productivity, focus on quality and developer experience metrics. Some of the examples are again code quality, build time, failure rates, onboarding time, code review time, developer happiness index. All of these would contribute to better predictability. If we know, like Sunit and Pinta was talking about in the previous session, if we know that API integration typically would take a couple of hours, but if to get the access and everything, if it takes 5 days, then we can't predict how long is it going to take to develop even a small feature. I have personally worked on a project where even a label change, a simple label change X to Y, would take anywhere between 3 to 5 days.
That's the reality.
That's a reality, and Sunit and I have worked on that project. So, sorry. Yeah, it was that complex. The things were made so complex that even a small label change would take that long to, take it to production. How to go about, measuring, or how to go about, measuring these metrics. So there are two parts to it. One is measuring, and the second is building intelligence on top of it. Right? We talked about measuring those different metrics, and there are different tools, developer tools to build those or measure those metrics. These are the platforms which aggregates this information from various sources and build intelligence on top of it. So it will show you the trends, it will show you how increase in, let's say, test coverage impacted the other metrics. Right?
I think the important part here is that this is solved problem. You don't have to worry too much around how to bring this intelligence for you, right, for your engineering. And there are many tools available in the market. You just need to understand your ecosystem, which tool can help you better in solving your problem, and based on that you can make your decision. Like similar to the business intelligence problem also, there are many tools available in the market, right? Same way you have to think here as well. You don't have to build everything from scratch. That's the point that we are driving towards. It's just matter of knowing it and making the right choices for your context.
Cool. How they work? Very simple. Collect metrics from various sources. Your GitHub, your source control management, your project management, your CI tools, your meetings, calendars, and so on. There are information spread across various platforms.
So if you look at here, this is a VDev, this is a picture taken from the site there. They say that 30 integrations are already built. Just have to integrate, start pulling the data, and they'll start showing the ready-made insights also for you to start consuming. But remember, this is always overwhelming. Sometimes you think all this information is available, let's start consume everything, and you go into the trap there. So first decide what you want to measure, what matters to your problem statement, and then based on that choose the tool available. Don't try to just think about, oh, this is giving 20 other metrics, let's use that, let's start seeing and observing all of that, which will not give you benefit at the end. But there are tools which works out of the box for you. They even go and monitor meetings as well.
Yeah, and it's easy to introduce tools, but it's difficult to manage them.
Yes, very good point. And get outcome from them.
The idea is to build intelligence in pockets and find your constraints. Where is your constraint? What is it that you want to improve? Figure that out, prioritize, try one thing. Don't get overexcited, like Sunit said, and we were discussing during the break as well, that don't get overexcited to just measure everything that is available. Try to measure one thing and see the impact. Again, as I said, tools are easy to integrate, to bring about, but difficult to manage. So here are the simple things, like where can you get started today? If you don't have those tools which we just showed you, you go just and sign up for those tools? Maybe not. There are simpler and low hanging fruits which you can go and try even today after going back to your work on work tomorrow.
So this kind of intelligence is already available in this tool. So you don't have to buy or integrate with new to get extra, but there are some simple intelligence already available for you.
Like for example, in your source code control management tool, you can have code commit analysis, you can have code review cycle time. There are plugins available. You can have max PR open count. Right? What that leads to, or what you should aim for, is only X. What are the number of commits that continuously integrate with your mainline? no more than one open PR. And that these would help you eventually, monitor, track, and see the benefits eventually. The project management tool have all the metrics. They are more matured and have all these metrics: ticket resolution time, lead time to change, bugs count, production incidences, and so on and so forth. All these data is already present in your current tool, whatever tool you are using. Every other tool these days are matured enough to spit out all these information, and the left hand side of that actually demonstrates that what you should aim for. Continuous integration and deployment tool, build frequency, failure rates, how many times do you have to roll back anything that you have deployed on production. It kind of gives you a glimpse of what you can try today in your current projects without introducing any further tool, and start monitoring them and have some sort of a benchmark to achieve the outcomes. Enough of talk. Let's look at some real example. Again, a disclaimer here. The reports I'm going to show is from a bigger project, so it's very contextual. We'll talk about the context as well. So here we have taken just one indicator, which is test coverage. So here you see the test coverage. The dark blue line that you see here is the test coverage over the period of time. The instant here you'll see the fall in the test coverage. That is because some big merge would have happened. This is a big legacy code base, and hence the code coverage is quite low. But over the period of time, if you see the blue line, the trend, code coverage is continuously going up. The yellow line indicates the average feature time to market. Right? How much time does it take to take the feature to the market? And the yellow line actually shows, this is sprint by sprint report. From and Jira. The yellow line actually, the lighter yellow line shows the trend, which is a downward trend. So the time to market is actually reducing. You are going to market much faster. Having said that, the test coverage is just one of the indicators to demonstrate. There were various other things that we need to do to bring this time to market down, but this is an indication, right? This is as test coverage increased, the average time to market decreased.
So single tool can give you one line, but the business intelligence platform tool can give you all these kind of correlations and show them to the others that okay, this is what is happening. We have to invest in test coverage so that we can have the time to market reduced.
And this, you don't need fancy tools. If you don't want to invest on any tool, just every sprint have the number written in an Excel sheet. Just plot a graph over a period of 8 to 10 sprints, and you'll start seeing those trends. It'll take 10 minutes. No. Sorry. No, the code coverage report is coming from our code the testing tool.
If it is published on SonarCube, yes.
Otherwise,
the code coverage, the blue line.
Yeah.
The yellow line is coming from Jira.
Yes.
That way, because it's a Jira features when it is going to production, right? You have every feature and stories on that, and based on that, this is plotted. So every feature which is going in, or the epic which is going into the production, is the yellow line there.
But when I don't see code.
Yeah. So the blue line is going up. So the yellow line is going.
The light blue line actually shows small. The trend.
No, the average. You see the average one? Yeah, because that is the trend, right? Because in some sprint you might see up and down, but you need to look at the trend more.
Makes sense? Similarly, the say-do ratio. Same test coverage, dark blue line. The dark yellow line is a say-do ratio. Say-do ratio is how much we have committed versus how much we have delivered. Yeah, that gives the predictability. Right? As you can see, the test coverage increased, the say-do ratio also increases. Again, this is one of the ways. There were various other things that we did to make sure that the say-do ratio keeps increasing and it has an upward trend. Defect density, another interesting matrix to track. how much are we delivering and how much defects are we producing while delivering those software. Right? So it's a simple defect divided by the velocity formula. And again, the yellow line, you see a downward trend. So we produce lesser defects when we are producing the code as the test coverage increases. Questions? Make sense?
Coverage increasing and defects less.
Yes, because I have more automated tests. So when it goes to the UAT and prod, I have less defects because my test coverage is giving me more upfront shift left kind of thing, right?
Correct.
Because I have my all the scenarios are covered in the automated test. So more you cover automated test, less you will see defects further down the line. Yes, test coverage is the kind of a metrics which will give me the indicator of how much automated test I have, because that's the test coverage thing, right? I think that's the point.
Time to merge. How much time does it take to merge a PR? Typically, many of us or many of the companies follow, before merging, you have to test it thoroughly. Whether if this branch is merged, you are not introducing new defects, you're not decreasing the code quality and so on and so forth, right? Again, you see the trend of blue line, the code coverage going up and the time to merge going down, because you would have covered most of these scenarios, you would have written tests around those scenarios for a reviewer to be confident that if there is a test for it, it will not break, the scenario not break.
Yep. Now all this looks good, fancy, yes, we can do all of that, but we would like to also talk about metrics are always a double-edged sword. It can give you benefit, but it can give you pain as well. If wrong metrics are measured, or you try to use them differently than what it's meant for. So what are the common pitfalls, or what are the other side of the metrics is? The first is at what level you measure the metrics, right? So we say that measure and collect metrics at the team level, not at the individual level. So whatever we present at test coverage is a team metrics, that the whole code base is what test coverage is, right? Don't try to go at the individual level, right? And do not use the metrics or to judge the individual performance. We start measuring, okay, how much code commit you did. You did 100 lines, you did 200 lines, you are very good, you did 200 lines, and that's how the whole metrics game can start, right? So I think we were talking in the last session about the how much review comment you have given to the reviewer, right? Or the co-developer is the metrics that we are trying to, and then we'll make a heroism there and find heroes who can give more review comments. So these are the we have to watch out for. So don't try to give metrics which can be a problematic. Whatever you choose for, right? I think it's again we have to apply our own due diligence around that, which is very important.
Yeah,
So
they say people behave as they are measured. So if you start measuring it at the wrong level, you might introduce new problems.
second one is the comparison. So what we have showed you is the one project over a period of time, and that's what you compare. That's what you see the trend. Don't try to compare across projects, because every project will have a different context, different setup, different types of languages used, legacy, modern, greenfield, all of that come into the picture, right? So look at the trend within the same project or application or code base over a period of time, then comparing across different teams and different projects. Try to improve that itself. That's the objective.
How many of us have heard about velocity as a typical comparison, that this team has 10 velocity, this team has 15. So 15 is better.
That's an anti-pattern.
Yes.
Exactly.
Because everyone can have a different, we don't have a measure of unit which is says square feet means square feet same for everybody, right? Everyone can have a different story points. I think
Companies are putting in that as one of the KPIs, 10% increase every year on year.
I think Jason is one of the best person to talk more about story points. I've read a lot of articles from him. So yeah. So that's very, you have to watch out for this. If this is happening, then we have to, as a leader, we have to stop this. We have to set this context, guidelines, guardrails around whatever we try to measure. The third one is overloading. Overloading single metrics with multiple purposes can cause many problems. I think try to have the objective outcome defined. Try to think from the perspective of what you want to measure, why. And the most important part, collecting metrics should not become a burden on the team. Oh, I want to collect this, but I don't have this. Everybody needs to do every day this one activity at the end of the day. And slowly there are 10 activities that everybody needs to do. Rather than think of an automated way to pull this data. It should not become a burden or an extra effort on the team. So again, going back to the examples where we say that, okay, to collect the metrics, you start saying developer to put every day this information in some form or Excel sheet. And then there are two problems to it. One, it becomes a burden, and second, people start giving false information. Instead of that, collect the data from the source. Try to see how much you can automate that, so that you can start projecting it from the actual data rather than people gaming it for that purpose, right? As Anand was saying, that it's very easy to game the data if you have all this manual process. So that's, you have to watch out for when you are looking at engineering metrics, because it can give you a direction which is not right, or it will create or cause problems in the team. That's all we have. So use engineering intelligence platform to boost your productivity, cut cost, align engineering effort towards the good business outcomes, business goals, and this will result in better developer experience, business, everybody will be happy. So again, I am going back. We have solved this problem for business. Can we solve this problem for ourselves? So we have to come up with our own engineering intelligence platform that can help us only, and will be able to give answers to the management or the stakeholders that what are the problems that the team is facing and how we can solve that problem, what are the kind of investment or the support required from the stakeholder to the team which can help to improve this. And when we apply those actions, are we seeing the trend in the improvement? So if I say I want to improve my onboarding time, I have taken 5 actions to do so, then when we have invested in that actions, are we seeing the result of it, benefit of it? That also we need to start measuring. I think this is the same exact philosophy or what do you call, gyan we give it to the business people, right? And we tell them that, okay, now you all should do this. Can we apply that same to ourselves? We have all the data available, as Anand was talking about. These tools are giving you the data. You can pull the data and then do the plotting and all that in Excel, or you can invest in the tool also, which will give you all this data metrics for your analysis as well. So 3 steps: collect the data, analyze the data, bring insights out of it, create actions which can help to improve this metrics. Fair? Want to add at the end?
No, pretty much covered.
And if you want to learn more about this, this is a small ebook published which is on the engineering intelligence platform on the ThoughtWorks website. So if you just search for it, you will get all of this information that we talked about in a small ebook. So I generally like this kind of a short. Articles are too small because we don't get too many information other than very snippets of it. A small ebook which we can read in the flight, finish it in one go in 1 hour, 2 hour, where you get the good snippet around it. So this is a small one which you can.
Sunit is the author of this book.
So it is there. So go through more details. There are some more examples given, and all of this documented there. So this presentation will be available also, but you can read through this as well. That's all we have. Thank you very much. We are good to done. Any quick questions?
Have time for questions?
Yes.
Yeah, any questions you have? Yeah, yes.
I'm curious what you've seen in terms of the, I guess like structure or processes around this. Let's say, just like with business intelligence, you just don't have the tool. There's things that happen, like where they review that. What have you seen in terms of engineering intelligence, like processes, structure, when you have this? Does that make sense?
Yes, so we have always a problem statement similar to the business problems, we have engineering problems, and that's what we have seen as a starting point. And then we start collecting data, we start bringing the insights to it, and then actions, and then monitoring it. I think that's
what I mean more is, so example.
Yes.
We collect stuff like this, presented it. There was a occasion where the CEO was there. First question was very polite. This stuff is really great, show improvement, but what value is this actually providing the organization from a high level, right?
Yes.
So, because even sometimes my reaction, like his reaction to faster delivery was, that's great, but faster doesn't mean more money, it just means faster. So there's this kind of step, and then that's kind of where I get to, okay, who's the customer for this? If it is very internal thinking, hey, engineering, you're going to think about and sort of measure certain things. If I go, oh, I'm going to have a regular operating review with product business people, I start to adjust even how I talk about this, because I have to probably, we just saying like, hey, what's the standard thing is usually dollars. So you say, hey, this is faster and this is associated with this amount of money, kind of thing.
Yeah. So I think it's very important, with Anand was talking about, is to map these two also to a business outcomes. And there is a kind of a framework or a book also written by a thought worker called EBO Metrics, Engineering to Business Mapping, how you go about it. So yeah, Anand wants to add.
I think in
You can use that tool.
DevOps also they say that it's not about ROI actually. The DevOps actually is not about ROI.
Yeah. To answer that question, I think we hear that all the time. The moment you go to any business and say that these are problems, they'll say, okay, but what is in it for me? But many a times, just measuring it and not doing anything about it, just measuring it and presenting it creates a lot of impact. Again, during the break, we were discussing that one of the well-known companies in Bangalore, we got 2 weeks to get a laptop, and their team was surprised that 2 weeks is very fast. 2 weeks we were doing nothing, just waiting for the laptop. And if these metrics just measured, no action, if this is presented to the CEO that this is the amount of waste that is being created in the company, that itself would have a lot of impact. Taking it, improving it is obviously the next steps, but yeah, just having it ready, just showing the impact to the business automatically will start making them realize that we need to fix this, we need to fix that.
And eventually it will help business. Eventually you can map any improvement that you bring to the engineering overall will help business and the product. So let's say if you start measuring more quality metrics, it will help you give better quality software outcome and a happy customer at the end, right? Because customer is happy, you don't have too many bugs, you are able to make faster delivery also because your testing cycle is improved. So that way it is helpful for the customer. They are getting features faster, right? Many of times we are building software for the internal consumer also, right? Within the organization, other business users are using that software. They can have a better day-to-day working experience for them without problems, right? When we go to the, because lesser defects is always better, right, in a way. Yeah.
I guess my comment is almost like it's almost like the next level, because defect density dropping is good. If I can associate, which sort of like my context, I know actually how much each one costs. Like, so it's like downtime, revenue loss per minute
Yes.
kind of stuff. If you can connect to that,
Yeah.
the conversation you're gonna have is a lot better.
Yes.
Perfect.
Thank
Because
you.
then
Good.
you can just go, a defect, because honestly, sometimes you can talk about defect rate and then you just go, yeah,
Yes.
whatever, I don't care.
Yeah, why
If
did
I
you
say,
introduce in the first place?
per minute we lose this much, that's what that means. And they go, oh, okay,
Yes.
now we have a
Agree.
conversation.
Very good example. Thank you.
And it's good for the team members to understand that too. So we understand like, hey, why are we pushing this? Because if it's down for an hour, then pretty much your salary.
Yeah,
Yes.
absolutely.
Thanks.
Thank
Yeah.
you.
Thanks, Anand and Sunit for this wonderful session on engineering metrics. Yeah, I think we'll have a lot of to take from this. And yes, a big round of applause to both of them. Yeah.
Thank you.